Okay, so today we're looking at the expression for Kc and the fact that this expression has units. Now Kc is to do with reactions that are equilibria. So they're reversible reactions that have been allowed in a closed system to reach a point where the rate of the forward reaction equals the rate of the reverse reaction, so that the amount of each chemical becomes constant. It doesn't change anymore. So here we have an equation. This is the Haber process, where nitrogen reacts with hydrogen to produce ammonia. Now we're just going to balance it with a 2 there. Now it's balanced and everything is in the gas phase. But the question is, if I let this reaction reach equilibrium, at equilibrium I will have some nitrogen, I will have some hydrogen, I will have some ammonia, but how much? The ammonia is the one I want. Will I have a lot of it? Will it be like 90% of the mixture? Or only like 3% of the mixture? That's a really important question. And the way we answer it is by writing the expression for Kc. Now to write the expression for Kc, this is a fraction. So I've got the numerator on the top and the denominator on the bottom. And the numerator at the top is the concentration of the products. So NH3, and to show its concentration I'm going to put it in square brackets. Now here is the hard bit. Not just NH3, but NH3 squared. And this is because of the 2. The 2 tells me to square this number on the top. Now if you didn't like that, let's see it again with the reactants. These guys go at the bottom. So first off we have nitrogen, so it's nitrogen. What about the nitrogen? The concentration of nitrogen. And this is raised to the power of, well, 1. So we don't usually write in a power of 1. Multiplied by the concentration of hydrogen. And this is raised to the power of 3. So it's cubed. And that is the expression for Kc. Now Kc also has units. And to work out the units, we first need to remember that the unit of concentration of anything, say a chemical, is always moles per decimeter cubed, or moles dm to the minus 3. So now if we put those units into our expression for Kc, you'll see that the units are moles dm to the minus 3 squared divided by concentration of nitrogen, moles dm to the minus 3, multiplied by moles dm to the minus 3 to the power of 3. Now we're going to cancel some of these out. Let's see it written properly. And this becomes moles squared dm to the minus 6 divided by moles times moles to the 3 becomes moles to the 4. Dm to the minus 3 times dm to the minus 9 is dm to the minus 12. Well, now we can do some more cancelling, and you can see these become 1 divided by moles to the 2 dm to the minus 6, which is better written as moles to the minus 2 dm to the 6. So before you go any further, please notice that the units of Kc are different for each and every expression. that while those are the units of Kc for this reaction, the Haber process, they won't be the same for all the others. And that's in worksheet Kc and its units for you to try.